Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, Managing Editor at Media Ops and moderator for today's event. We have a great webinar on tap as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains the link to access the webinar on demand. And we are taking questions from the audience. So if at any time today during today's presentation you have a question, please use your GoToWebinar control panel and submit your question. We'll try to get to as many as we can near the end of today's webinar. And finally, we are doing a drawing at the end of today's webinar for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Autonomous Incident and Root Cause Detection. Our speakers today are Larry Lancaster, who is founder and CTO of Zebrium, Scott McAllister, who is developer advocate at PagerDuty, and Gavin Cohen, who is VP of product at Zebrium. Gentlemen, thank you all so much for joining me today. I am so excited about this presentation.
Hey, thanks a lot for having us. Really appreciate it.
All right, great. Well, Larry, I know you're going to be kicking us off, so I'm going to put myself on mute and let you get right to your presentation.
All right, thanks. Hey, everybody. So it's a really exciting opportunity to share with the audience kind of what we've been doing, and we've got some fantastic people here with us. Scott McAllister from PagerDuty especially is joining us, and I really appreciate, Scott, that you showed up. So with that, I'm going to go ahead and get started. So I want to set the stage a little bit with what's sort of the problem that we noticed in the market and we set out to solve. So, you know, what we're seeing today in terms of sort of, you know, monitoring is that even the best sort of DevOps teams out there are having trouble with sort of the unknown unknowns, right? Sort of the kind of problems that happen in production, and since the symptoms, sometimes the symptoms and almost always the root cause is unknown, then resolving that incident becomes, you know, a manual effort, and it's a real time sink. And so MTTR today in a complex deployment has become a real pain point for teams out there today. And so that's kind of the problem we're looking to solve. You know, it's interesting when you step back and look at, you know, over the last 10 to 20 years, you've had a huge increase in complexity of deployments and in potential incidents within those deployments. In addition, with sort of the move to SaaS, right, what we've seen is that, you know, the impact of an incident can be much greater. You know, it used to be 20 years ago, you know, back when you had support departments and you had shrink wrap software, that, you know, if there was a support case or a bug, it would impact, you know, one account, one customer at a time, you know, maybe a handful of users. Today, you know, if you have an issue in your production deployment as a SaaS company, the impact can be across tens of thousands of users. But at the same time, you know, our bandwidth as people has not gone up. And so how can we sort of approach the problem of reducing MTTR given these parameters, right? That's kind of what we're out to solve. So for us, the solution is to try to apply some of the techniques of modern machine learning to sort of assist a person by showing them what to look at. So as opposed to the expectation being that an SRE or a DevOps person would go and sort of have to instrument you know, detection for all kinds of, you know, unknown unknowns, which is an unreasonable expectation. Let's help out with that. So when we look across kind of the, you know, the telemetry solution space today, you know, what we see most of is sort of tools that, you know, will let you ingest your telemetry, your logs, your metrics, right? And you can go in, you can search, you can set up alerts, you can chart, but it was pretty clear, you know, we needed to go kind of beyond that. The next class of solutions that you'll see out in the market today are sort of anomaly detection solutions. And so, you know, there are vendors who sort of, you know, go and try to find, so let's look at your metrics and let's do some forecasts, or let's let you put a model in and kind of detect anomalies on those. There are even some, you know, solutions that try to give you anomaly detection on your logs. Right, and so that's all really valuable and definitely has been a step in the right direction, kind of trying to surface the things that an operator needs to pay attention to, right? But the problem there is, you know, anomaly detection solutions are generally kind of, they're kind of noisy. So you're going to have maybe thousands of anomalies a day in a big deployment. And so are you supposed to sift through all those, right? And how do you do that? So really we felt there was another step that needed to be taken. And we're calling that incident recognition or incident detection. But the idea is pretty simple. And the idea is this: let's take a look at, you know, those anomalies that we detect across your telemetry, and let's see if, you know, if any of them sort of form a pattern of correlation that makes us feel that there's something generally disruptive happening there. And what we'll do then is we'll open an incident report, and that's one thing that we do. And today we'll be talking about something that's a little bit more sort of, you know, more mainstream use case, which is, you know, maybe you already have alerts set up in a you know, like a Prometheus, or, you know, maybe you've set them up with, and you're opening those and sending alerts to PagerDuty. And so given that signal, can we go and sort of augment that alert information? And so that's kind of what we're here to talk about. So we believe that by taking that extra step of creating incident reports and telling you what to look at, we can save you a lot of time. So here's kind of a really pretty pictorial representation of what we do, and I love kind of watching it. So let me talk a little bit about what we're showing here. So the idea is that you've got telemetry, you're collecting logs and metrics. You know, you send that to us. You know, if we have collectors for all kinds of stacks, but, you know, in some of them it's just a, you know, a couple of Helm charts in Kubernetes. The non-Kubernetes collectors are really easy to deploy. Step two, basically we start looking at that data as it's coming in. We structure that data a bit, and I'll talk more about the technology in a little bit. And the next thing you know, we've sort of mapped out kind of the structure of the data and the normal sort of operational patterns of the application. And what we'll do then is we'll start being able to notice things that are weird, and create an incident and alert you. And so now I'm going to talk a little bit about the technology behind that, so you understand kind of what it's taken to be able to do that. I'm really excited to share our technology with you. So in that vein, I'm going to switch into, you can see the slides just went into Death Star mode. So this is kind of my technical presentation, and it's kind of my favorite part. So, you know, why is it really hard to kind of, you know, automatically detect without alert rules incidents? You know, and I'm going to start at the beginning and talk about, you know, let's talk about the hardest part, which is the log data itself, right? So if we want to support free text logs, which we do, then you have to understand that there's a lot of sort of troubleshooting information that's in those logs. You know, chances are pretty good that you know, if it's a new incident or a new issue that's surfacing, you're going to end up in a log file looking for root cause. So it stands to reason that a tool that's going to surface that for you automatically is also going to have to dig into the log files. And so let's talk about those challenges. So the formats of log files change, and I'm sure you're all kind of familiar with this. You know, you'll set up maybe a regex or alert rule or something on a, you know, to look for a particular log message, and then some developer somewhere that doesn't really owe you a notification will do something really nice for you, like fix a spelling mistake. And the next thing you know, your alert rule is kind of silently broken, right? And sort of along those lines, if you set up, you can set up sort of regexes and not be aware that pattern may match multiple kinds of events that you didn't mean to catch, or there may be variations in the one you did mean to catch, and you don't have kind of a template for that. Beyond that sort of thing, though, and this applies to all data types, is that you need someone to be able to interpret that data, right? To tell you whether, so for example, if I'm an experienced sort of SRE on a particular application, I just kind of know certain things without having to express them. I know what's unusual. I know, like if I saw something unusual, I would know it. If I saw something bad happening, I would know it. And without that context, it's difficult to start putting together an incident report if you don't have that kind of context. And apps are bespoke, right? So let's say we had connectors and rules and all kind of stuff for a whole bunch of your sort of components of your stack, but then there's your application, and there's not going to be a connector for that. And so how can we look into that data and surface something meaningful for you? It's really hard to instrument for the unknowns. So the way we go about that is a multi-step process. So the first step is, we'll take a look at the log and metric data as it comes in, and we'll structure it relationally. And I'll tell you a little bit about what that means. So essentially, what that means for logs is, you can imagine for every unique event type, right? If I were to collect data for a day, maybe I have 1 billion log events, right, that I've collected, but there will only be a few thousand kinds of event, right? Unique event types. And so imagine each one of those has a table with typed columns for all the parameters. And we'll load the data into those. We'll take our best guess, and then we will refine that asynchronously over time. So if we get a new version of a message, we'll take those two tables we've created and we'll merge them into one. So there's a constant learning that takes place. So because of that, and we do it sort of inline at ingest, there's no batch process that goes back and looks. You don't need to give us any sort of known prefix formats or connectors. You don't need to give us any sort of log types, specific keywords to be able to structure things. You don't need to give us a grammar, and we can embrace the free text logs. So as an example, if we take this very simple example, and this, it's kind of unfair because most free text logs are much messier than this, but the point is to be able to give you a sense of what we're doing behind the scenes. So up top there, you see some lines that may be printed in a log file, and what you'll see to the left there is the prefix, which is going to have stuff like PIDs and function names and whatever else, timestamp. And then over to the right, you see kind of the free text portion of the event, right? So what'll happen in our system is we'll look at that, and we will create a table, something like the structure below, where we're saying, this event type, when we try to construct a name for it, and then we, figure out what are sort of the parameters of that. And so we take the constant parts and put those into the name, and we take the variable parts and put those into the column names, and we populate those and we type them. And this is what we have behind the scenes. So that's how we're able to start doing really good anomaly detection on logs along with metrics. Now we do also structure the metrics. We have a high efficiency Prometheus scraper. We've open sourced it. It's in our GitHub. So we also support sort of JSON metrics. If you have a log stream that has metrics in it, it's pretty easy to rope those in. The most important thing here is simply that we collect all the necessary metadata to be able to structure it into tables. And what we end up with is the logs and metrics are in the same relational database on the back end. So that gives us the power to do analytics really quickly, and be able to sort of pick out when there's a new type of issue going on. So once you have all that data in one place, right, it's really easy to kind of create dashboards. We support Grafana and all of that. But I think the purpose of this is just, besides to show you really pretty charts, is to kind of get across the concept that that we have all this in sort of one place. Step 2 is anomaly detection on this data, right? So remember the pyramid, we started with collections and we did our own structuring. Now we're in the anomaly detection part. But our goal here is not probably what most anomaly detectors would have as a goal. Our goal is to make sure that we capture anything that is even remotely anomalous, because we're not afraid of being verbose here. We want to make sure we capture all the signal we can out of the data, because this is going to support our next sort of layer, which is the incident detection. Right. So if you think of the anomalies, you could think of them as features, right? You're kind of extracting features from the data, and you're doing that with an eye towards creating the incidents. So an example would be, you know, I want to make sure I have all sort of, you know, local sort of minima and maxima of a metric and its first derivatives, and I have all of those kind of cataloged, because later I can look to see whether those correlate with anomalies in my log streams. What we try to avoid is being too complex. You know, we want the stack to run fast. We want to keep costs down for users. We're not using neural networks at this point in time. We're using a fairly simple stochastic model to look for cross correlation. And we try to avoid a lot of you know, sort of assumptions. Like, for example, you might have an assumption where, you know, like, for example, if I'm doing forecasting on a metric, what I might end up doing is having to say, well, I'm going to assume that I can learn the patterns of the metric from, you know, last month, and it should be the same this month. And you know, what we're trying to do is be responsive to incidents that can happen today on a newly deployed version of your application. So we try to avoid that kind of long-term, you know, assumptions of sameness. Right. So in the end, what this gives us is the ability to kind of trace the unknown. And that's really the purpose, because we want to solve the unknown issues. We want to get that root cause in front of you. So what that means is you don't need to give us any connectors or knowledge bases, any specific application behaviors you don't need to give us. We don't code anything into our code base. If you look at our code base, there's nothing that says anything about, you know, replication, database, Apache, or, you know, keywords like fail or oops or something like that. There's nothing in there that talks about those things outside of the basics of sort of, you know, identifying which parts of, you know, a log message are the severity and all of that, right? But that's very generic stuff. It's not, we're not giving any rules at all about the application. And so what that means is, out of the gate, you can expect it to work great on your own bespoke app. Right. So the last bit here I want to touch on is kind of the correlative part. So this is, you know, you can kind of think of this, you know, in terms of tracing, right? So as an example, in tracing, what you'll do is you'll use sort of a trace ID that, you know, that kind of binds together different parts of your telemetry with the trace data itself, and so, you know, you'll use that as a way to kind of localize and, you know, all the data for an incident. That's kind of how the system does it. And the way we kind of figure out, okay, all of these are part of one sort of incident, and we should put the report and show a user, is by using a correlative model across all the different generators of metrics and logs. So, for example, you know, we'll notice that this stream over here tends to correlate to a certain degree with this stream over here, but all of a sudden we get anomalies in both of them, and they're highly correlated anomalies. We'll know that those things are related to a high degree of certainty. So we've replaced a sort of a trace ID with a representation and say we're pretty sure that this is all related. And so that's kind of how it works. The idea being, we can create you an incident and root cause report without any instrumentation having been required. And what's really cool is we'll be able to walk you through a demo and give you an idea of what that means as a user. And with that, it's demo time. So I'm going to go ahead and make Gavin the presenter.
Okay, thank you, Larry. Okay, so thanks for passing that over, Larry. So what you're looking at now is the overview screen of the Zebrium UI. And this one is actually monitoring the logs and the metrics from the Zebrium production instance of the Atlassian software. So internally, we run Jira, Bitbucket, Confluence, and so on. So let me quickly page through the overview screen, and you can see there are some details on the CPU utilization and the memory utilization. We show you a chart over time of errors and anomalies. Now, as Larry mentioned before, you always have anomalies. That doesn't mean there's a problem. It just means that there are anomalous patterns in your logs and or metrics. And then as we move down, you can see the top error and warning events, and we can see the top anomalous events and what we call ghost events, which are events that have stopped. But what's really more important is that inside this, and I should point out, there is only 151 megs of logs and 51 megs of metrics in this whole instance of data that we're looking at. And that's the entire domain of what Zebrium has learned on. So inside this, our machine learning has uncovered 2 incidents, and that's really the thing that is of most interest to someone who's using the tool. So let's take a look. Now, in this screen, this is our incidents screen, you're presented with a 1-line summary of what we believe is the most important events for 2 of the incidents. And you can see they both occurred last week. So let's take a look first at this one, and then I'll come back a little bit later and I'll show you the second incident. So in this case, it's actually a fairly clear-cut incident. And it starts, well, I should point out, it spans Bitbucket, Postgres, Jira, and Syslog. So it's a cascading incident that moves across multiple different logs. In this case, the incident was detected only in log events, but we'll show you a little bit later what metric anomalies would look like as part of an incident as well. And it tells a story. So it starts here. We see actually a very clear-cut message saying the Postgres stopped, and that's in syslog. But what's interesting here is this is not an error. So this isn't an error that we were programmed to detect. This is actually an info level message that says Postgres stopped, and then you see a stopping message. But almost immediately afterwards, we see the problems start to occur. So remember, Postgres is now stopped. So you can now see Jira application is having trouble collecting metrics. And then there's a Jira exception here while talking to SQL. So trying to execute a query. And the problem continues on. I won't go through every event, but you can see, for example, this is when Bitbucket is also impacted. So there's another exception, a fatal exception. That was actually the one that you saw in the summary, which is also quite an ominous looking event. But it really tells a very clear story. Postgres stopped, and then the other applications were impacted. Now, let me really clearly point something important out, which is there was no rule to look for any of these log events. These were picked up because there was a cascading pattern of abnormally correlated anomalies across lots of different log streams that we were receiving. And that's what triggered this incident. Now we can go further. As I said, in this case, it's a fairly clear-cut story, but let's say we want to troubleshoot further and see what else went on. So I drill down, and now I'm taken to our log viewer. And you can think of our log viewer really as a full-blown log management tool, and I'll show you some of the other features we support in a moment. But we're taken into, to start, a filtered view which shows the same events that you saw on the previous screen, but this time they're displayed much like they would be in the raw log files or log streams if you were to look at them. And you can see there's some syslog, Jira, Postgres exporter, Bitbucket, and so on events. But here's our stopped Postgres message that you saw before. And we have a few shortcuts to make troubleshooting very simple. The first one is I can peek. And what peek does is it takes me into the log stream where this particular event occurred. So in this case, it's going to take me into that particular syslog log stream. And you can see here's the same event. So we can see what happens before and what continues to happen after that those events occurred. Okay, so that's one shortcut to drill right down into an individual log stream, and we could have done that for any of the other ones. Going back to our filtered list, so remember this is a filtered list only showing the events that made up the incident. I can turn off the filter and now see what happened before and after those events. So now I'm looking at all the logs being collected or that were collected at that time in time series order, aggregated together in this view. And what's interesting here is that immediately before you get the stopped Postgres message, you can see that someone called Rod logged in as user root and actually shut down Postgres. So here you can actually see in the auth log file the command that was used to shut down Postgres, which is what caused this whole problem. So that sort of sheds a little bit more light. And I can scroll through and I can see where all the other incident events land in this sequence. But essentially, we really already have what we need. Now, let me show you a few other pretty cool things that we can do with our UI and enabled by all the machine learning and structuring. So remember, Larry talked about the first phase of machine learning, which is structuring events. Well, when I mouse over any event, you can see that there are some words in blue and some in white. So the words in white are the fixed part of this event. That means there are other events that look just like this with the same text in white, but that have variables, the text in blue, that have different values in different instances of this event type. So in this case, the word stopping is actually a variable in this event type. So let me right-click on the word stopping and say display chart. And what I see here now is we're charting the value of that variable. So you can see over here is the stopping version of that event, and then the stopped, and a little bit later we get, like 2 minutes later, you can see the starting Postgres message. Now, it turns out that if you were to look through all those log events, that Rod actually then came back in, and 2 minutes later he started Postgres again, and then all the apps recovered soon after. So here you can see the time sequence of stopping and started and so on. That's because we're charting a variable that our machine learning parsed in that event type called PostgreSQL cluster. We also support full regex search. We can filter by log type, so any of the log types that are being streamed in, we can filter by severity, by labels, which is really cool in a Kubernetes environment because we pick up all the default and custom labels that are associated with each log line. We can set up our own maps here of queries. We can set up alerts and rules if we want to be explicitly alerted on something. But essentially, what you've seen so far is entirely enabled by our machine learning. So there was nothing in Zebrium that told it to look for that particular incident. So what I'm going to do now is hand it back to Larry, and actually, sorry, I apologize. I'm going to hand it to Scott McAllister of PagerDuty, who's going to talk a little bit about the incident response process and then also how Zebrium actually can help with that. So I'm going to pass the slides back now, and thank you, and we'll show you another demo in just a minute.
Awesome. That was great, Gavin. Yeah, so at PagerDuty, we're going to talk about a little bit about incident response. Today, we've been talking a lot about incident detection and leading cause detection. And I wanted to talk a little bit about what happens when things go not as planned. And at PagerDuty, this is how we define an incident. You might define it differently. The key is to keep it simple, keep it within a sentence, but make sure the definition is something that everyone understands and everyone's on the same page. As we see on the next slide, when an incident is triggered, we automatically change the way that we're thinking. Our adrenaline starts pumping, our decision-making changes, and at PagerDuty, we call this wartime, where we switch our day-to-day operations, or peacetime, to focus on defending the business. Now, you might not like using the word wartime or peacetime, so as the next slide, you can see that you can say, the situation is either normal or not normal, okay or not okay. That's fine, as long as you all agree on your teams. What's important is that you make a mental shift that this time is a time to keep your system running and to find what's going wrong. The most important advice you can have when heading into an incident is on the next slide. This is key. Definitely, as you panic, panicking is contagious. And as we panic, it raises the stress level of everyone around you and also makes the incident response not go well. So one way to remain calm is to clearly define roles on your response teams and also have clearly defined processes. In the next slide, we learned that at PagerDuty, we use something called the incident commander process. And the incident commander is essentially a person on the incident response team that is in charge of making the decisions. They're the ones who make all the calls. They're the ones who gather the information and give requests. You also have subject matter experts who are the ones actually digging into the issue and actually combing through the logs and things. But the incident commander is the one that directs how things go. And how they make these assignments, we'll talk about in the next slide. The key is to communicate clearly. There we go. And so that essentially when you have an assignment, you don't suffer from what's called the bystander effect. You don't say, can someone do this? You actually address a person directly. So in this case, our commander addresses Rachel and says, I'd like you to increase the latency. And then gives her a time box that says, could you do it in this amount of time? And then waits for Rachel to respond. That way, both parties understand what's going on and both understand what the request is and that it was received. You definitely want to keep communication open so that you can solve your problems quickly, but also solve them with the least amount of stress. The communication, the stress level goes high, so the communication is definitely could be urgent, but you don't want to be a jerk. So definitely keep realize that people are human on your team. And remember, on the next slide, our goal for incident response is to limit the damage that the incident is causing and to reduce the recovery time and costs. We do this with two main objectives. First, we want to restore our service as soon as possible, essentially the short-term solution to keep things running and afloat. But second, we want to figure out the causes of the incident and to establish long-term solutions. Both of these objectives require extensive knowledge of your system. And as Larry mentioned earlier on at the beginning of the presentation, once upon a time, our systems were fairly simple. There was code running on a box, maybe another box for a database, and that was about it. Maybe some client-side code in there. The idea of having an engineer who knew most of your system or even every corner of it was pretty good. But nowadays, there are so many different services. Think of the services, all the ones you build internally, and then all the ones you depend on externally, and all the different infrastructure pieces, and all the different configurations there. The complexity is immense. And as Larry was talking before, there's definitely going to be some unknowns as you're going through when an incident occurs. Now, going through these things, we'll see in the next slide, the SRE handbook lists some pitfalls to troubleshooting. All of these pitfalls that are listed here track back to the idea that sometimes there are parts of our system we just don't know, or we just don't understand, or we don't understand the changes that we make and how they will affect our system, which will increase the amount of time that it takes for us to resolve an issue. What we want to do is keep in mind the different aspects that we have, the knowledge of the different people on our team. We need to trust those people, but not assume what we think may or may not be true. We want to definitely know and make our decisions on the data that we find. Now, after an incident is resolved, that is the time that we can learn. In the next slide, we use our opportunities to review, not to point blame, not to get people in trouble, but to learn from how we can not repeat history and not make the same mistakes again. Some organizations even take these reviews and the reports that they make and make them public. There is a zine that I learned about recently called the Post-Incident Review that publishes a lot of these public post-mortem or post-incident review reports for the rest of us to learn from. And in one of those reports, there was a software company that I'll keep them to remain nameless at this time, but they had an incident where they went down for 45 minutes, and after the 45 minutes, they discovered that the issue was caused by a very well trusted, very stable third-party library that they were using for key value pair storage. And there was just a super unique situation that was causing a problem that their whole system wasn't responding to correctly. Now, I don't point this out to point fingers at this particular situation or this particular company, because all of us have been in that situation where we've been hunting down for the cause of a problem. If you go to the next slide, we see that this is mentioned is because this is common. Think of all of us who have gone through issues that we've done. We've had incidents occur where something will happen, it will go into a tool similar to PagerDuty, and then when PagerDuty alerts our teams and we assemble our response team, our subject matter experts are going to be digging through those logs. They're going to be digging through those dashboards and finding metrics, whatever they can see, to help them figure out what they want to do. Now, I don't know if this particular company that took 45 minutes to figure out this issue had help with something like Zebrium, but if you look in the next slide, you could have Zebrium assist those subject matter experts, and also, as you saw in the demo before, how you can make those correlations between the different logs and the different tables that you need and the different metrics that you need to help you come to the decisions faster. Now, I don't want to go into too much more detail because I don't think I would give it justice. So I think I'm going to give it back to Gavin to kind of describe what Zebrium does in more detail.
Wow, thanks a lot, Scott. Really appreciate you coming and sharing that perspective. I mean, that all resonates. I think that resonates with what we've seen. I think PagerDuty's, probably at the center of a lot of these sort of incident management issues. So I really appreciate that perspective. That was awesome.
For sure.
So, right. So I think, kind of what's interesting about what we're trying to provide, using PagerDuty is, so if I created an incident in PagerDuty, then what I'm going to want is something to help me resolve that incident. That, maybe you have tools that will, create incidents, and sometimes Zebrium can do that. We have outbound webhooks to do that into PagerDuty. What's, I think, sometimes even more interesting is an incident's been created. We know roughly what time that was. So we have an integration now together with Zebrium and PagerDuty, where what'll happen is we'll be notified and we'll gather up any incident reports that we've created around that time, as well as go digging even deeper for other anomalous information at the time of the incident. And we'll put that into a separate report, and we'll put this information into the PagerDuty alert itself. So we're feeding back into that workflow to give you all the information you need right in front of you. without having to worry about, oh, now I need some kind of an AI ops tool because I've got incidents coming from here and incidents coming from there, and how do I merge them? And nobody has time for that. So that's kind of what's really exciting about this sort of approach.
Yeah, that's super cool.
Awesome. Oh, I see.
Larry, if you want to pop the next slide. So I was going to do just a quick second demo, and we'll demo exactly what Larry said.
Yeah, let me hand it over to you. Hold on.
Thanks, Larry.
Yeah. Make presenter.
So yeah, as Larry said, we've integrated in collaboration with PagerDuty, and we're going to show you a demo of what that looks like. And it's pretty cool. So we actually had an incident last week, and just to show you exactly what it would look like, we're going to show you the sequence again today. Now, I'm going to start, and I'm in Slack, and we've set up PagerDuty to alert via Slack. So I'm going to ask my colleague Rod now to replay the incident, or to trigger the incident as though it's exactly as it would have triggered last week. And what you see here is there was a little pause between two messages, but the first one comes from PagerDuty. And that's because the APM tool created a critical alert which triggered PagerDuty to create an incident, which essentially said there was a health rule violation. Okay, so this was created by the APM tool, nothing to do with Zebrium. But with the integration that we have with PagerDuty, PagerDuty then called the Zebrium API to augment the incident. So almost immediately afterwards, Zebrium came back with something over here. Now, let me explain what happens. Three things occur when we're asked to augment an incident. The first thing is we look back half an hour for any incidents that we've already detected, and we pull those or push those into the incident that was created inside PagerDuty, because more often than not, they're related to what the incident is. So these are incidents that occurred within half an hour before. The second thing we do is we continue to look for incidents in the next half an hour, and if any occur, they'll also be pushed into the same PagerDuty incident. And that's really helpful because whoever's troubleshooting typically wants to know other things that are continuing to go on, because sometimes you have one incident followed by a set of cascading incidents. And then the third thing, which actually just happened, so you probably, if you're watching the screen, just saw another message appear, is we create a synthetic incident. And inside the synthetic incident, because now we have a positive signal from PagerDuty to say there is an incident taking place, Zebrium creates a synthetic incident that pulls together all the other anomalous events and metric patterns into an event. And these are the ones that wouldn't normally make it to the level of being part of an auto-detected incident, but because now we know there's an incident taking place, they're typically very helpful for troubleshooting, and that's what you see over here. Now, I'm going to click on this to go into the PagerDuty view of all of this. So we're now inside the incident from PagerDuty, and here you can see some details of what actually happened. So this is the APM tool saying essentially that a login time exceeded 60 seconds. We can look at the timeline, and you can see over here is where the incident triggered, and Rod triggered it through the API in this case, but normally it would be auto-triggered by the APM tool as it was last week. Then we get Zebrium augmenting it, and it gives you this one-line incident, which looks like an interesting event. What I'm going to do now is I'm going to click the link that's inside the PagerDuty incident, and that takes me into the Zebrium UI, and we're going to actually take a look at what Zebrium saw. And this is the really cool augmentation, because remember, all we know at this point is what the APM tool said, which is login time exceeded 60 seconds. Didn't give us any more details, and it said that because there was a predefined alert. So now let's take a look. So this purple or this colored message here is the one that you saw inside the incident. And that's essentially a Java exception saying that it couldn't create a session. Now, Java not being able to create a session is very much in line with probably a login timeout. So it probably had something to do with the login process. But let's look for more detail, okay? So in this incident, you see there's a couple of metric anomalies that we also pulled in. And the first one is a Java virtual machine memory pool that had some values that suddenly dropped. So you can see it's going along and there's this big drop here, which is coincidental with when the other events occur. In fact, there's actually a second drop a little bit later, probably related. So that's kind of interesting. So at this point, you'd probably say, okay, there's some sort of a Java or a JVM issue, and that's the root cause of why there was a login timeout. But we're not done yet because Zebrium's pulled together some more events. So let's kind of move up, and I won't look at every event, but here's a pretty interesting one, okay? And this one is from the kernel. So the log type is the kernel log. And essentially it's saying that the kernel invoked the OOM killer, sorry that it spans 2 lines here, but the out of memory killer. And that's because it saw a process called OOM test that was consuming too much memory. So now we're sort of getting more to the heart of what happened. It actually turns out that our colleague Rod had run a program called OOM test, out of memory test, and its sole purpose is to consume as much memory as possible. So what actually happened was it had nothing to do with a Java issue or a login issue. It was that this OOM test process was basically chewing up and asking to allocate more and more memory until eventually it had taken all the free memory from that host away, and it starved Java and everything else. And then you started seeing all the Atlassian apps become impacted. So you can actually see that we've detected issues in Confluence, Bitbucket, Jira, and so on, all related to this essentially root cause, which is this OOM test program. Now, I should point out very clearly again, we didn't build a rule for this. We didn't say, look for the kernel message that says it invoked the OOM killer. This all was picked up because we saw this cascading pattern of abnormally correlated anomalous log and metric values occurring at that time. And so here's
Gavin,
an example.
Can I jump in really quick on that? So this is a great example, and I love how you've walked through it. So for everyone on the line, like, to understand kind of how Zebrium works, if you look at this, what you'll see is 2 kinds of events that are pulled into this virtual trace. So when we talk about Zebrium incident, usually that's because we've created an incident, but in this case, we're taking this same incident information, we're putting it into PagerDuty incident, right? So here, what you're looking at is kind of a virtual trace of what happened. And so what you're seeing is a couple of different buckets of stuff here, and one is rare stuff that's happening. Like, it's going to be very rare that you see an OOM killer run. I would imagine it's not happening all the time. It's not happening every minute. It's not happening every hour. And so that's going to kind of upregulate the likelihood that event will show up in a trace. You're also seeing some really bad stuff that doesn't usually happen. So down below that, you're seeing a whole ton of symptoms, right, of that problem. And so what's happening in our system is we're looking at that and we're saying we have something that's really rare, right? And we also have something that's really bad. It's very rare. It's not very often that that something is this bad. So what's the likelihood that really rare stuff and this really bad stuff happened within 2 seconds of each other? And that likelihood is very low. And that's how we decide to create a trace from it. Thanks, Kevin. I didn't mean to.
No worries, Larry. Actually, with that, I'm going to hand the slides back to you and maybe just wrap up quickly, and then we can take any questions.
Sounds good.
I know there have been a few, so let me make you the presenter.
Okay. All right, thanks. All right, so Right, so there's some real life incident detection examples here. I don't want to spend too much more time without getting into questions, but these are on our website. I would really encourage people to go there, check out our blogs. You get a lot of information about the kinds of incidents that we've caught in the wild with customers. We've been deployed on over 100 different stacks and have looked at and created over 1,000 different virtual traces. And many of those we've received feedback on and use that feedback to make our software better. So I think the takeaway from these sort of incidents that we have caught is not that we, look, we catch this kind of incident. It's that, this sort of general approach we've taken of, intensive structuring, anomaly detection, and then a correlation model across different services has given us the power to detect all of these with no instrumentation and no alert rules, right? That's really the takeaway. So with that, let's go ahead and get into some questions.
Excellent. All right. Well, we have about 4 or 5 minutes for questions, so I think we can get to 2 or 3. So why don't we go ahead and dive right on in. The first question here came in rather early, so I think maybe, Larry, this one might be directed at you. How do you manage the data growth?
Okay. So, right. So you're going to have, a certain retention time, which, depending on your plan, and it can be long, right? It could be 90 days. So the question is, you've got all this telemetry coming in, how are you able to scale? So our backend, is completely scale out. We have a scale out MPP relational database that we use to store the data. We're kind of built for this. I mean, in our previous lives, we had sort of a machine data sort of telemetry database that we were running services out of in the multi-petabyte range. So we kind of know how to manage that. But the important thing is that in the core of it, you do have sort of a shared nothing architecture.
All right. Let's see. Next question here. This is interesting. Impressive supporting interface. How big is the dev team?
Oh, good question. So engineers only, we're looking at 9 people.
Not bad. All right, great. Let's see, here's a good one. We have inventory suppliers who inform us of outages on their end through emails. Can we have Zebrium see these emails and include them with all the logs, metrics, etc. for incidents? Or would we post the emails to Slack, for example, and have Zebrium collecting info from specific channels?
Oh, that's a great question. In fact, that last use case, we actually do support. So you can use Slack as sort of a, as a place where you're, managing, coordinating incidents, and we have an app for that. Rod, you want to just chime in really quick on how that works? Just the 1, 2, 3 of that.
Yep. Can you guys hear me?
Yeah.
This is Rod. So I run engineering at Zebrium. So yeah, so we have a Slack app now. So it's kind of similar to the PagerDuty incident in that we take external signals from literally several different apps. So of course, PagerDuty being one, Slack being another. So you can actually just ask Zebrium for help. So you can say, let's say you're working in the war room that Scott mentioned, and you have an incident going on right now. Maybe you don't have PagerDuty integration yet, but you have Slack. You can simply use the Zebrium / command to ask us to analyze for any incident in time. You could just say now, or you could say an hour ago, or what have you. And we'll do exactly the same thing that you saw happen there in that PagerDuty demo, but we'll do it from a Slack signal that you type in at the Slack command line.
Very cool. Very cool. All right, great. I think we have time for 1 or 2 more questions. Next question here. Can you correlate with a change, such as Kubernetes deployment or scale up down?
Yeah, absolutely. So anything, so we would want to get that as sort of a signal and treat it the way we're talking about the signals we'll take from PagerDuty or potentially from Slack. But we can absolutely work with that. All
right, great. Next question here. So does Zebrium replace AI ops tools in the market, or does it complement it?
I mean, so I think, you know, like, so when we talked a little bit about sort of the Zebrium trace and the incident itself, which is being managed in PagerDuty in this example we went through, you know, you can see that what you really want as a user is you want it all in one place, right? And so so AIOps is, you know, it's kind of there because tools don't work that way and they don't play well together, and some of them are noisy. And so, you know, it's kind of working on this high level sort of summarized events that are coming from tools, right? I think there's definitely, you know, that's a valid thing, you know, to do. There's a pain point around how other tools are operating. What I would say though is when there's an incident happening, what you really need is something that's going to dig down into the telemetry itself to surface root cause, right? That's really where the value is going to be for you. So I would say it's complementary in the sense that I don't think that we're trying to do necessarily the same things at all.
All right, so complimentary then. That's awesome. All right, guys, it's we're about 4 minutes to the top of the hour, so unfortunately that is all the time that we have for the question and answer period. If we didn't get to your question, I apologize, but please know that the folks at Zebrium are getting a copy of all of the questions that came in, so I'm sure they'll be more than happy to follow up with you offline to get your question answered. I also want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. All right, I also mentioned at the top of the hour that we were going to be doing a drawing for 4 $25 Amazon gift cards. So without further ado, why don't we go ahead and do that? Let's see, today's winners. Our first winner is Charles M. Congratulations, Charles. Our second winner today is Garrett S. Congratulations, Garrett. Third winner today is Jan M. Congratulations, Jan. And our final winner today is Pete T. Congratulations, Pete. Check your inboxes, guys, because we are going to have an email with the $25 Amazon gift card in it. So check your inbox, as I said. If it's not there, check your spam folder. All right, guys, I want to thank Larry, Scott, and Gavin for such a great presentation today. Lots of really great information. Love the demos. And judging from the number and quality of questions we got in from the audience, I know they got a lot out of it also. So thanks again, guys. We appreciate your time, appreciate your expertise.
Right on. Thank you. Thanks,
All
Scott.
Right, great.
Yep. Thank you.
Thank you.
Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody. Please stay safe.